Let's solve the problem. And solving this problem, I will assume from the very beginning that you have no idea how to approach the solution of this problem. So I will do everything slowly, step by step. So first, what you have to do, of course, you have to read condition of the problem. A car slows down uniformly from a speed of 28 meters per second to rest in 8 seconds. How far did it travel in that time? So first of all, I recommend you to grab all numerical data you have in your problems. So you have 28 meters per second, and this is speed. If it's possible, try to figure out immediately, is it initial speed or final speed? You have condition that the car slows down uniformly from the speed 28 meters per second, so this is initial speed. So this is V initial. Next one, you have final speed, which is 0 because car ended up being at rest. So V final is equal 0 meters per second. Look, one number we are given, another number hidden a little bit in the words and the condition of the problem. One more chunk of numerical information we have 8 seconds. Clearly that this is the length of the time interval during which car was slowed down from 28 meters per second to 0. Now, sometimes in the condition of the problems you have hidden information. What I mean by that? In case if you have vertical motion, you deal with the gravity and you have gravity acceleration 9.8 meter per second square. It's not relevant in this particular case because we have horizontal motion. We have the same heights all the time and the motion happens to occur perpendicular to the gravity acceleration. So we do not need to take into account this acceleration for this particular problem. Next step, you have to visualize situation. Just draw the simple but informative picture. I will draw the horizontal path. I will show the car originally. It doesn't matter how good your picture will look like, but you have to show this. I will indicate that initial velocity I do have, and this is 28 meters per second. Then I have final velocity of the car, which is 0. So the car is at rest. Now, what do I have to find? I have to find distance between initial position of the car and final position of the car. So basically this length I have to find. I put here question mark. This is my initial point. This is my final point. Now, in addition to that, I have time to pass this distance, which is 8 seconds. Now, look at the condition of the problem. We are told that the car slows down, which means that the car has acceleration, which has to be directed opposite to the initial velocity to be able to slow down the car. So we have acceleration, but we do not know this acceleration at all. We are not asked to find this acceleration, but it's better to indicate that we do have a known quantity in this particular case. Now, after you have this picture, you have to switch from the distances shown here by question mark to the coordinate. In this case, you have to pick up axis. Axis is better to pick up always over the direction of the motion. In what direction, to the right or to the left, doesn't matter, but it has to be along the direction of the motion. I will put my axis X, let's say, to the right, though it's not necessary. You're completely free to pick up any direction. And to be able to talk about coordinate, we have to set up origin. We have two special points, initial and final. Each of them can be used as the origin. I will put origin, let's say, at initial point. In this case, automatically, x initial will be equal to 0 meters. And x final, if you look at the picture, will be unknown quantity we need to calculate. After you have axis and origin, all numerical data reflected on your picture, you have to list all known quantities. Quantities for which you have numerical values. I know V initial, I know V final, I know X initial, and I know delta T. I am looking for the X final. After you have this list of known and unknown quantities, you have to look at your formulas and pick up formula which will have everything known and unknown quantity. Clearly that in our case, that will be the second formula, which looks like x final equal x initial plus v initial delta t plus 1/2 a delta t square. But in this particular case, we have two unknowns. We have x final and we have acceleration. To be able to use this formula, we have to find time from another formula. So we need to have system of two equations. But you do not have to follow this way because you have easier way. Just continue to look at the list of the formulas, and the last third formula you will have will looks like x final equal x initial plus v final square minus v initial square divided by 2a. Can we use this formula? Nope, because we again have x final and a unknown. So the only way to solve this problem is to find delta t from another condition, not delta t, a, acceleration, and then put acceleration in one of these two formulas. The only formula we did not use yet is formula for the velocity. V final equal v initial plus a delta t. Look, in this particular formula, we know v final, we know v initial, we know delta t. So we can find a from this formula as v final minus v initial divided by delta t. If you put your numbers, you will have 0 meter per second minus 28 meter per second divided by 8 seconds. And you will have negative acceleration. Negative corresponds to the picture because the arrow which corresponds to the direction of acceleration is opposite to the x-axis. So you have minus 28 divided by 8 meter per second square. So minus 28 divided by 8 meter per second square. After you have this acceleration, you can use either of these two formulas given to you, whatever you like. If you will decide to use, let's say, first formula, this one, you will have x final equal 0 meters plus v initial 28 meters per second times 8 seconds minus 1/2 times 28 over 8 meter per second square times 8 second squared. And you have to solve this numerical formula. 0 means nothing. Then you have 28 times 8 meters because seconds will be cancelled, minus one of the 8's cancel be here. So you'll have 1/2 28 times 8 meters. And finally you will have 1/2 28 times 8 meters, or 28 times 4 meters, or if you will do multiplication, you will have 112 meters. You solved the problem completely.